the Nuwa app that you use for your field data collection with the Tersus solution. So on the left-hand side here is the app icon. We'll tap on that. Now when Nuwa opens, it's going to automatically connect to the last device that it used. But for this overview, I'm going to disconnect it. At the bottom of the screen are the 4 main function groups. You've got projects, device, survey, and tools. You can slide left to right, or you can tap on the names of each one of them to switch between them. There's also a more button here. You tap on that. You can rearrange the icons by holding down on them, or you can hit the minus button to remove them, and then they'll always be available to re-add. When you're done with the customization, you can click up here in the right-hand corner on the red letters to exit the edit mode. All right, so we'll start project up in the upper left-hand corner. This is used to create a new project or open an existing one. We'll come back to that in a bit after I go through a few of these other ones. CRS, that is your coordinate system. This is where you will find your predefined coordinate systems that can be imported if they're not in the list. You can also create a new coordinate system and create your own user-defined coordinate system that can be saved as a template. At the end here is tap fitting. This is the PPP service that you can get through Tersus. If you're going to be using that with your job, then you'll want to go in and select NAT83 for that, and it'll put in all your parameters. Next is code. At the top right-hand side in the first icon, you can import either a .cod or .fxl file. And the second icon allows you to export the codeless file. So when you click add, here you can select it as a point or a line feature, color, and we can add attributes. The types are either a value or you can do a list. All right, the next one is point. So this is where you can add or view the survey, control, and staking points. You can slide left to right on here to check your point information, or also to switch between your point styles. Under survey point, you can add a point manually by entering in the info and the coordinate type. In edit, you can go in and change the code, antenna type, or the antenna height. If you have any base or calculated points, you cannot edit any of that information. When you have a point highlighted, if you hit details, it's going to give you all the information about the point that was collected. Under control point, you can import points from file, survey point, or you can manually add them. And staking, you can also import same styles, but also from control point. Next is line. Under line, we have survey and staking line as the options at the top. If you select survey line and hit add, you can give it a name, a code, and then you can add points to that. Under staking line, you hit add. You can choose what type of line you want. And depending on what type of line you choose, you'll have different methods of staking out that line. You can give it a name. We can pick our start point from the list, or we can grab it off the map. Give it a start station. You can toggle if you want to do point on line staking in your interval, and an offset from the line. So next is road. This contains a variety of feature factors. The software currently supports the use of station equation, intersection method, or element method to edit the road's alignment, vertical profile, cross-section, super elevation, and widening. We'll get into this in a future video, but this feature is included with the Nuwa app and does not require an additional purchase. All right, next is Surface. So at the top, you can import a file to be saved as an area. At the bottom, you can create new or edit an existing. So we'll click on New. And then you can create a surface from selected points or from boundary points. Click Add, and then it takes us to the list of our survey points. You can do a quick search, and let's change the point type to continuous. And now you'll see it only has the continuous points. We can do a multi-select, select all. And now you see they're all in here. You can give it a name and an offset. Hit save. And then it's going to give us a nice little preview of our surface. Then we'll go to import. In here, you've got either a coordinate import or an other import. The coordinate import will let you pick a point or a line where you want those points to land with stakeout, controller, survey, their format, and the path where you want to import it from. Other import will let you choose from other file formats like DXF, shape, or land XML. Put in your unit, type, again, where you want those points to land, and then import once you pick its file path. Next is export. Here you can pick your coordinate export, what type of point you want. You can pick from a date range. Your format again, give it a file name, and then where you want that to be exported to. Other export has a few more options than your other import. Settings. So this is where you can change your coordinate display, coordinate order, your units, your decimal places, and down here they have update detection. This is recommended to leave on. When you first open up the software, it's going to notify you that there is an update. It's going to list out what those new features are that are coming with the update, and you can update it then. It takes less than a minute like your normal apps do. If you don't want to do it though, you can wait and tell it that you want to do it at a later time. Here you can shut off the controller voice. And then also you can change the user interface style if you like. So we're in grid right now. We can change it to list. Pop back. You can see there's a little bit different look if you like that look better. And the last one here on the project screen is cloud settings. So you can register under here, and you can use this to set up the Tersus GNSS cloud service that provides the Tersus software users with cloud data storage, synchronization, and management functions. So we'll go back up to project here. We've walked through all these. Here at the top, you've got your cloud options if you want to upload it to the cloud or download one from the cloud. This is going to tell you your current project. You can open up an existing project, or you can create a new. Here you give it a project name, creator. If you had a project template that you wanted to use, just tap that on and then select which project source you want to use. Coordinate systems. Your code list. And then down here at the bottom, you've got your geoid model. If your geoid isn't enlisted in here, you can just tap more, and you can can go import 12B if you need to. Click OK, and your project's created. I'm going to go back in and open up this one called the Nuwa Overview, as I have some data in there that we're going to use as we go through the video. All right, so we'll move over to the Device tab, and we'll start with Connect, and we're going to pick our antenna type. We're going to use Luca as our base. I'm going to do a base rover setup for this overview. But notice you can also use down here at the bottom, you can use the internal GPS on your device, or you can pick simulation. For this overview, we're going to do a base rover setup. So once we're connected to our base through Bluetooth, we'll go tap on base. We have receiver network options in our work mode list, and we also have internal radio. Receiver network would be if you wanted to use SIM cards and use the Tersus caster service of just doing a internet connection between your base and your rover. But we're going to do radio, so we'll tap on that. We have details. So now in here you can enter in your base coordinate that you're on, or you can even tap that icon, the waypoint icon, and it'll give you a rough position. We put in our antenna height here. And we're measuring it to, there's an arm extension that comes with the kit, and that is measured to slant. We're going to use the internal radio. We can change our air baud rate, the power. Luca has a 1 watt, Oscar has a 2 watt max. Protocol, which we'll leave at TT450S. We're at 12.5 bandwidth, and then we can pick our channel and the correction format that we want to use. So everything looks good. We'll start the base.
Configure base successfully.
All right, once we got the base started, we'll back out. We're going to go up to connect again, and then disconnect from our Luca base. We're going to go pick our Oscar serial number and hit connect. All right. Once connected, we'll go to Rover, and we're going to pick our internal radio one, but we'll check just to make sure we have all our settings correct on here, what we want to use. Looks like everything matches what we had at the base. We'll hit start.
Configure rover successfully.
So now we're up and running.
Float.
See, we've changed to float, and we should initialize here and fix. All right, so now we'd be ready to go over to the survey tab and survey, but I just want to point out a few other things on this screen. All right, so tap would be if we're going to use the PPP service, but since we're already connected to the rover and we have that going, all that is going under there, and you just tell it to start. If I go under it now, it's just going to show that we're already going with the rover. NMEA output, you can go in here and push it out through the serial with whatever settings your device needs. Device, this is just going to tell us what type the device is, what firmware on. We can check for a new version of firmware if we wanted to right from here. We don't have a new version. Lets you know the battery, temp, how much free space we have. Do tilt, we can do an IMU calibration. You can toggle on here for change battery. There are hot swappable batteries in the Oscar. You can adjust your electronic bubble. A few other information and settings in here that you can mess with on your receiver.
After getting our GNSS system running, we'll go over to survey function and tap on the survey icon. First up at the top of the screen is the easy way to toggle between your map view and a detailed text-based interface with a simple click of this icon. The next line down, we have the satellite icon. provides a real-time view of the number of satellites being used in your current solution. Understand your position accuracy instantly with the solution status indicator. White signifies no fix, yellow indicates a float solution, and green confirms a fixed and reliable position. Keep an eye on the data link with the displayed age of the differential correction. If this number appears in red, it is higher than the set limit in your survey configuration and is a clear indicator to check your base source connection. The tilt status icon clearly shows when tilt compensation is enabled, along with its quality. Simple tap allows you to toggle this feature on and off as needed. Always be aware of your power level with the battery icon, displaying the remaining battery power of your Tersus GNSS receiver. The next line down is the input bar. It provides essential information for your next point, showing the name, code, and the line it can be associated with. Selecting a line name here will automatically connect the subsequent point to that line. The icon located below the input bar on the right-hand side is your gateway to the survey point library, allowing you to easily view, edit, or delete your stored points. Right below it is the map icon that lets you quickly switch between satellite, street view, vector background maps, or turn them off entirely. Need to perform line work? The next icon provides access to powerful drawing tools. You can select from polyline, polygon, square, rectangle, circle, or arc. The red dots serve as a visual cues indicating the specific information required for each drawing type. The waypoint icon provides a convenient tool for on-the-fly measurements. Finally, the information bar at the very bottom offers quick access to 6 key data points, all of which can be customized to display the information most relevant to your current task. These additional interface elements provide you with the crucial information and tools right at your fingertips, further enhancing your surveying efficiency and control. Next is point stakeout. For efficient stakeout management, the flag icon located in the upper right-hand corner provides direct access to your stakeout point library. Here you have the flexibility to add individual points or import multiple points to your list seamlessly. Directly below the map icon, you'll find 3 navigational arrows. These intuitive icons allow you to easily move to the previous or next point in your stakeout list. The center icon offers a smart shortcut instantly directing you to the nearest point. Experience enhanced stakeout precision with the AR icon. Selecting this feature utilizes your controller's camera to overlay augmented reality guidance on the live screen, clearly marking the direction and distance to your target point in real time. Once you approach the target, the system intelligently switches to a 3D display, providing an even clearer visualization of the target's direction and location, ensuring pinpoint accuracy. With these advanced stakeout tools, navigating to your target points has never been more intuitive and efficient. We're now going to delve into the versatile line stakeout features available to you. Directly below the map icon, you'll find 2 navigational arrows. These intuitive icons allow you to easily move to the previous or next point in the line. The system supports 4 distinct types of line stakeout: straight line, polyline, arc, and circle. Each of these offers various methods to suit your specific needs in the field. For enhanced organization, you can easily modify the name of your line stakeout. Additionally, you have the option to enter the mileage at the starting point of your line. When point-on-line staking is activated, you gain the ability to define the precise distance between the points you are staking out along the line, ensuring accurate placement. Understanding offsets is crucial for accurate line stakeout. Remember, a negative offset value will position your staked point to the left of the defined line, while a positive offset will place it to the right. These comprehensive line stakeout options provide you with the flexibility and precision needed for a wide range of surveying tasks. In site calibration, we'll explore the powerful coordinate transformation and height fitting capabilities of the system. For precise height fitting, the system offers 3 distinct methods: fixed difference correction, which requires just 1 point pair; plane fitting, utilizing 3-point pairs, and surface fitting, which leverages 6-point pairs for more complex terrain adjustments. Select the method that best suits the complexity and accuracy needs of your vertical data. The system uses the calculation of a 4-parameter plane transformation, allowing you to seamlessly align your survey data with different coordinate systems. To utilize these features, you'll first need to add or import your point pairs. Once your data is ready, simply select your preferred method of calculation. You have the flexibility to calculate both horizontal and vertical transformations simultaneously, or you can choose to perform either adjustment independently depending on your project requirements. These advanced transformation and height fitting tools ensure the accuracy and consistency of your spatial data, regardless of the coordinate system or terrain variations involved. Next, let's dive into the survey configuration. Here you can set up your survey limits. Below that, you have the flexibility to choose your preferred survey mode, whether you need detailed measurements, continuous data collection, control points, or an offset. Further personalize your survey by adjusting the survey epochs and how point names are automatically incremented. For added confidence, activate Survey with Confirmation. This handy feature will present a dialog box for you to review and confirm details like the point name, code, antenna information, and even attach a photo before saving the point to your library. If you prefer a faster workflow, simply leave it off and the points will be saved directly. Keep your focus on the action with Auto Center. When enabled, your survey graphic interface will automatically center to your current position every 5 seconds. Need quick access to frequently used codes? Turn on Quick Code and they'll appear right on your screen. You have 5 pages with 10 customizable buttons. A long press will allow you to easily modify or delete these shortcuts. Stay audibly informed during stakeout with the stakeout prompt tone. When navigating to your stakeout points, activate Auto Zoom. The graphic interface will dynamically zoom to keep both your current position and the target point in clear view every 3 seconds. Achieve precise stakeouts with the stakeout tolerance setting. You'll receive an audible beep every second when you're within your defined tolerance. Tailor your stakeout prompts with options like north and south or forward and backward direction, ensuring clear guidance. Adjust the frequency of your stakeout prompts. Selecting high will refresh the text more frequently than once per second. For CAD stakeout modules, you can change the unit to US feet for your drawings. And finally, at the bottom of the interface, you'll always have quick access to crucial antenna information, including the type and height. These customizable settings are designed to enhance your efficiency and accuracy in the field. The other tab under Survey Configuration is for the display. This allows you to customize the information you see. Choose to display point type, name, code, all staking points, or an electronic bubble for leveling, all tailored to your preference. This segment will guide you through the powerful surface stakeout feature. This allows you to stake out points based on imported 3D surface data from DXF or LandXML files, or surfaces created using TIN data. To add a stakeout surface, click the flag icon. This will allow you to import 3D surface data, or you can create a new TIN model by selecting points from your library. If needed, you can edit your imported or created TIN. This includes adjusting offset values and modifying the individual points that define the surface. Once your surface is ready, select it from the list and begin the stakeout process. As you move within the defined surface area, the software automatically interpolates the design height based on the underlying 3D surface data. It continuously calculates the cut or fill value by subtracting your current height from this design height. To provide immediate feedback, the software uses intuitive color coding. If the design height is lower than your current height, indicating a need to cut, the height deviation will be negative and displayed in red. Conversely, if the design height is higher, requiring fill, the height deviation will be positive and shown in blue. Surface stakeout provides a powerful and visual way to stake out points based on complex terrain models, ensuring accurate earthwork and grading. Let's explore the configuration options for static observations within the system. Here you can define the recording interval and the total duration of your static observations. You have the flexibility to choose from a predefined list or manually type in your desired values. Next, you can set the elevation mask angle, which determines the minimum elevation above the horizon for satellites to be included in the observation. The station ID defaults to the first 3 and last 5 digits of the receiver's serial number for easy identification. However, you can easily overwrite this with your own custom identifier. You'll then specify the Rhinex format for your output files, the antenna type being used, and types of measurement. In this case, we'll be using slant, which is relevant for the ARM extension included in the Tersus base kit. Following this, you'll enter the antenna height. The recorded antenna type setting controls how antenna information is recorded. When turned off, the antenna type will not be recorded, and the antenna height will be saved as the phase center in the Rhinex header. When turned on, both the antenna type and the height to the bottom of the receiver will be recorded in the Rhinex header for more detailed documentation. Finally, the data autosave feature manages your recording sessions. When enabled, the receiver will automatically close the current file and start a new one once the set duration is reached, ensuring continuous data collection. If turned off, the receiver will stop the static recording entirely when the specified duration is complete. These comprehensive settings allow you to precisely configure your static GNSS observations to meet the specific requirements of your projects. Road stakeout will be detailed in a dedicated future video focusing on road construction and surveying applications. With the integrated CAD stakeout and CAD survey features, you'll have the ability to directly import industry standard DWG and DXF files into the system. Once your CAD file is imported, you can seamlessly select specific points and lines directly from the drawing for stakeout operations. Conversely, during a CAD survey, you can survey new points and lines in the field, and these can be directly referenced against the elements within your imported CAD file for real-time comparison and verification. This direct compatibility with CAD files streamlines your workflow, allowing for efficient stakeout and survey tasks based on your design data. In base shift, we'll cover an essential procedure for maintaining accuracy. If your base station has been inadvertently moved or restarted at an unrecorded position, it's crucial to perform a base shift to ensure the integrity of your collected survey points. To correct for this, utilize the calculate function within the system. This feature will allow you to determine the precise shift that has occurred. By using known control points or other available methods within the software, the system will calculate the necessary translation to realign your base station's position. Once the shift has been calculated, you can then apply this correction to all the survey points you've collected, ensuring they are accurately referenced to the correct base station location. The last segment is visual positioning. This feature is currently available with the Oscar Trek receiver. Notice that the main interface now displays the live view from the Oscar Trek camera. In the upper right-hand corner, you'll find the precision estimate for the Oscar Trek. If this estimate is too large, the camera icon will appear in red, indicating a need for adjustment. To improve the precision, simply shake the pole or move the Oscar Trek according to the on-screen animation. Once the requirements are met and sufficient precision is achieved, the icon will turn green and the animation will disappear. When you're ready, click Start Vision and ensure the Oscar Trek remains directed toward your target points. Proceed to walk at a normal pace, keeping the Oscar Trek facing the points of interest. Once you've captured the necessary visual data, click Stop. A dialog box will then appear, allowing you to change the name of the photo group and see the quality of the captured images. Please note that the detailed process of performing visual measurements using the Oscar Trek will be covered in a separate dedicated video. The last function group we'll explore is tools. Each tool provides a graphic interface and the necessary input fields to perform various calculations. First, inverse allows you to calculate distances and bearings from point to point. and from point to line. You can create offset point from an existing point or line, calculate a rotation point, and determine various intersections including 2-point, 4-point, and intersection angles. The area perimeter tool can be used to calculate both the area and perimeter of a selected region. Earthwork is a powerful tool that allows you to calculate the volume formed between two surfaces and a reference height, providing total cut and fill amounts. Grid to ground lets you select a point as a datum, calculate a scale factor, and then apply that factor to your entire project. The angular bisector tool helps you accurately divide angles. Line segmentation allows you to calculate points along a line by specific segments or at a defined interval length. With points average, you can calculate the average of all selected points, displaying both the average results and the difference between the individual points. For coordinate transformations, the parameters tool offers a 7-parameter calculation requiring 3 known points in your local datum in WGS84. For a simpler 3-parameter calculation, at least 1 known point is required. Finally, area division provides 2 methods for dividing an area: swing line and parallel line. That concludes this comprehensive video on the overview of the Tersus Nuwa software. As you've seen, the software offers a wide array of tools to meet your geospatial needs, all with a user-friendly interface. Thank you for viewing. Skål!